So, good afternoon, everyone. My name is Aditya Vaidya, and I will be discussing with you our research paper named Smart Waste Monitoring System using IoT. So, basically, sanitation of the surrounding is crucial for a healthy lifestyle. During the course of our daily lives, garbage bins are completely left unattended. They are completely loaded or spill out onto the surrounding and results into environmental pollution. This poses a major risk to both the environment as well as to the human health. Thus, the garbage bins need to be monitored and managed in smart cities to provide a safe and clean environment. The real time monitoring and control of trash disposals is a very hard topic that requires mm, thorough, mm, thorough attention, and current technological improvements are also needed. So basically, our system integrates the traditional waste management procedures with the modern IoT infrastructure. So the main objective is to uh, establish a clean waste management system that assess the level of waste on dustbins through sensory systems. So we have so reviewed these documents while we were understanding our research paper. So the first paper, efficient garbage disposal management in metropolitan cities using VANET. So basically, the authors have proposed an efficient method to dispose the waste that has been designed with wireless sensor networks using VANETs. For efficient communication, they have used IEEE 802.11p, and multicast routing has been suggested for implementation in garbage collecting vehicles. And the second proposed method, smart and wireless waste management in IEEE sponsored international conference. The authors have proposed a solution mm, called a smart garbage bin, which will alarm and inform the authorized person. So basically, when the garbage bin is about to fill, mm, uh, they have suggested a method to separate the five types of plastic resins um, by utilizing the NIR spectroscopy and then using the remaining biodegradable waste to make biogas, depositing the garbage in a landfill. The third, solid waste management, green index calculation and route optimization method, uh, it basically tells how to tackle segregation at source. And a term called green index is presented in this that illustrates the degree of greenness of buildings. The routes taken for waste collection are another area that is addressed. So, in the final proposed system, survey on IoT-based smart cities, a smart bin is used on a single location, or it is also used in a collection truck. And the smart bin is composed of sensors and gather all the information from the bin, and they deliver the real-time data to the main centralized processing system. So this is the overall block diagram. So we have specifically used node sensor for our proposed system for its low cost Wi-Fi microchip. It has also a built-in TCP/IP networking software and microcontroller capability. With a self-contained SoC and an integrated TCP/IP protocol, it allows any microcontroller to access your Wi-Fi network. And we have also used an ultrasonic sensor. The ultrasonic sensor is basically used to determine the level of the trash can, and the output from the sensor is sent to the signal and is to be processed by the node MCU. Here, the HCSR04 is the ultrasonic sensor we have used. Here, the trigger pin receives the controlling signal from the node MCU, which is the input pin, and the echo pin is used for sending signals to the node MCU. And load cell. So we have used a load cell, and it basically an electrical signal is measured and standardized is produced when a force or a tension is collected. The electrical signal adjusts proportionately to the amount of force being exerted on the garbage bin. Then the overall the status of the bin is displayed on a LCD display. And we have also used as a buzzer to indicate if uh, the status of the bin is exceeded a threshold value. So we have specifically used ultrasonic sensor for uh, for level detection of the trash bin, because the sensor provides a non-contact range detection between 2 centimeter to 400 centimeter, and it is very suitable or compatible with the dustbins that are being used right now. So these are the ultrasonic pins and descriptions. We have also used an HX711. It is an integrated IC. It is a 24-bit analog to digital converter that is used for weighing scales and industrial control applications to interface directly with a bridge sensor. So this is the overall flow chart of our proposed system. So basically we are going to initialize all the sensors. And if the status of the bin, so the status of the various garbage bins are under observation, obtained using the various sensors like ultrasonic sensor and gas sensor. The level of the dustbin is given on the dashboard in percentage of each garbage bin. The level of the dustbins is monitored, and the garbage bin filled about the threshold value of 75% is required to be empty. The status shows the level, weight, and any presence of any unpleasant gas. The route of the garbage collection is displayed using the web page. The route is determined using the location of the garbage bins. This route is the shortest path for garbage collection for garbage bins, having status more than the required threshold value. This basically improves the waste collection process by saving resources and time. So this is the PCB design of our proposed system. We have also did the simulation using the Proteus software. In this, we have used gas sensor, load cell, and the ultrasonic sensor. So it detects on the serial monitor, we get the results as this. If the status of the bin is above the threshold value of 75%, so it will be indicated as a bucket full, and other parameters are also displayed. So all the dustbins are then being prioritized based upon their status, and an optimal path for waste collection is produced. So we can collect the waste in a given amount of time. So this we have integrated. So this is the status of the 3 bins. We have used PyCharm ID for creating the web page. We have specifically used PyCharm for better visualization of the status and collection of the route of the garbage bins in the system. So it also displays the dustbin ID, dustbin location, and the current fill and last recorded. So with the help of this, we can record the amount of waste that is generated on household level, and we can then we can decide, or we can provide much more proposed systems how we can minimize the overall waste generation. So the expected results are to find the shortest route for garbage collection for area under observation in order to reduce the use of amount of resources and to increase the efficiency of system. So so in this system, the system efficiently achieves waste monitoring by the probability of waste levels in the trash bin and provide the shortest path for area under observation in order to reduce the amount of resources used and thus increase the efficiency of the system. So these are the references that we have used.
So thank you, sir, for your kind presentation.